Okay, everyone, I'm going to start the session because I just want to make sure that I solve all these quiz problems for you. So if you're just walking in, just put your Scantron on the pile of Scantrons and then your solutions on the other pile. So let me do this. Okay, first of all, I asked you to also give me your solutions. And I received emails that, it wasn't clear. I didn't tell you, you didn't receive notification or, some, things like that. And here, when you take the test, you should read the instructions. So here, I clearly asked you to also give me your solutions. And here, I told you why I needed the solutions. So at this point, if you didn't give me your solutions and only gave me your Scantron, I encourage you to do two things. Whether you can do the quiz again, write your solutions and send them to me, email them to me. And if that is too much work, you can just schedule a meeting with me, whether you come during my office hours or just like send me an email, schedule a time, whatever works for you. And then come to my office and then explain to me how you solve the problems. You can also schedule a Zoom meeting, whichever is convenient for you. So is there any questions about that or is it any difficulty? Yes. Run-through hall 001. So I don't want to make your life, difficult, but I want to make sure that you solve the quizzes, the quiz basically yourself. And I wanted to see what are most common mistakes, kind of to have an understanding of what I should work on with you for the final exam. So I really needed that. So whether, do the quiz again and write the solutions and send that to me, or if that's too much work, schedule a meeting with me and then just walk me through your quiz and tell me how you solve the problems. That is that. Any other questions? Okay, and for the exam, I also, there were like some confusion about what is on the exam, and I think I clearly told you that chapters 5 and 6, and that was, the materials for your quiz 3. So chapter 7 would be on your next exam. But I tried when I taught part of chapter 7, I tried to go through naming ionic compounds, kind of explain, reviewing the other chapters. So it wasn't like detrimental for your exam. And also, I'm going to give you periodic table of elements and the table of polyatomic ions. Those two things. So at the end of your exam, you are having like two appendixes, one of them for polyatomic ions, one of them for like the periodic table of elements. So be aware of that. Any question about that? Okay. And also, I'm going to, look at your solutions today, and tomorrow after like 10 a.m., you can stop by my office to pick up your solutions. But I'm also going to, walk you through the quiz now, so you have this recording available for you for the later use. So, okay, let's go through the quiz. So, the first one, what is the correct chemical formula for lithium phosphate? How would you write the chemical formula for lithium phosphate? So first you say, your cation is lithium, and this is, among that table for metals that have only one charge. They have set charge or like fixed charge. That you should know. There are like group 1, group 2, zinc, aluminum, silver. You should remember that. And then phosphate. And I told you that I'm going to give you the table of polyatomic ions, which are here. Okay, so you go see where is phosphate here. So you write that here. So you have 1 positive charge for lithium, 3 negative charges for phosphate. And in general, your compound should be neutral. It shouldn't have any charges. So how many lithium should I have for that to have charge of +3? Yes. So the first one is like Li3PO4. And as you can see, there is just like one answer that contains that. So for your exam, if you're sure about something, you can just like answer the question. But I'm going through the other one so you see the procedure. What is the charge for calcium? Yes. So it's alkaline earth, group 2. It has always charge of +2. What is nitrite? Yes. So in order for this compound to be neutral, how many nitrites should I have? Exactly. And then you go through your answers, you see 2 of them have that. What about aluminum? What charge aluminum has? 3. What about oxide? So for these ones, you should find the most common denominator, which is 6. And then in order for Al to be 6 positive charge, you should have how many of that? What about oxygen? Exactly. And then iron 3 oxide. So iron 3 is like Fe, 3 plus. What about oxide? Again, the same thing here. You should have like 2 of iron, 3 of oxide. So any question about this? Is this clear how we name these? Yes?
I have a question just not about that. I was wondering if I could take a picture of what I answered so I can compare it with what you're describing on my thing that I turned in. I just want to take a picture.
If you can do it at the end of the class,
Okay.
that would be great. Okay. And also I'm going to turn it back to you, give it back to you. Okay. So now if there is no question, I'm going to go to question 2 to make sure that I do this in a timely manner. Okay. So which statement is not correct? Matter is ultimately composed of atoms, and those atoms are often combined in compounds. True or false? True, right? The formula mass of a compound is the sum of charges of all the atoms in the chemical formula for the compound. Exactly. So we don't have, it's not the sum of charges. What is it? Exactly. And then besides being the characteristic mass of a molecule or formula unit, formula mass is important in many calculations involving the composition of compounds and quantities in chemical reactions. True or false? Yes. Most of the matter you encounter is in the form of compounds. Exactly. And as I said, in your exam, you have lots of definitions. So if you have difficulties with definitions, go back to the book. You have the online book now. And if you don't have access to that, I uploaded the instructions to how to get access to the book in the website and then the access code and everything. But still, if you have difficulty, just email me. And then I'll send that to you separately. So next question. What is the formula mass of CCl2F2, hydrobromic acid, phosphorus pentafluoride, and manganese 3 oxide? As I promised you, I'm going to give you periodic table of elements. So let's see. Okay, let me do this instead. Can you read the numbers? Okay. This is, I guess, the best it can get. So, do you remember how to calculate formula mass? We say 1 multiplied by carbon plus 2 multiplied by atomic mass of Cl plus 2 multiplied by atomic mass of fluorine. And then you go to your periodic table, you read this number for C. For carbon, this is 12.01. For Cl, this is like 35.45. For fluorine, is 19. And then you add these numbers. So this is roughly 12. This is like roughly 70. This is roughly 38. And then when you add these two, it would be roughly 120 just by looking at the number. But you put that in your calculator and then get this number. And then as you see, all of these are the same. So this didn't help you a lot. But hydrobromic acid, what is the chemical formula of that? Yes. And then for finding formula mass, you go to your periodic table, read the number for hydrogen, which is 1.01. It's kind of like hidden here. It doesn't show on my screen, but it's on top left. Plus bromine is like 79.90. So this number is roughly 80, as you can just look at it, right? But the exact number is this. So now your answer is between B and D. And then if you're short on time on exam, you can just go see, okay, the other two numbers are the same. So let me do the last one, which is manganese 3 oxide. So even if you have an element that is not in the table for the cations that have variant charges, I told you, remember invariant charges, which were like group 1, group 2, aluminum, zinc, silver. If it wasn't them, the other ones have like, variant charges, and you can see here that it told you that the charge is 3. So manganese is Mn. 3 plus, oxide is O2 minus. And now you learn that it would be Mn2 or 3, like we wrote it for aluminum oxide. And then to calculate that, I'm just going to write it here, would be 2 multiplied by Mn, which is 54.94, plus 16 multiplied by 3. And this number, so this is roughly 55. It's 110. This is like 48. So, okay, did I make a mistake? Oh no, here I have it. I wasn't seeing this. Okay, cool. So roughly it's 158, but of course you put it in your calculator and then you get the exact number, which is 157.88. So now you know the answer is B. But for the sake of just learning, let's go through phosphorus pentafluoride. When you see penta, what does it tell you? Yes, and it tells you that it's a molecular compound, right? So phosphorus, you go to your periodic table, you know phosphorus is P. And then fluoride, it was fluorine, which was like base name of nonmetal plus IDE. And as you guys said, it's 5. So what is atomic mass of P? Can anyone tell me? Yes. Plus, how many fluorine do I have? Yes, multiply by 19, right? So this is 94. This is roughly 31. So the answer would be 126, roughly. And you put it in your calculator, you got the exact number of this. So any question about this problem? Clear? Okay, let's see if I can just, okay. Trying to keep the periodic table. I guess at this point I cannot, they are just merged together. Anyway, I bring the periodic table again. So it says, imagine we have 10 moles of the following compounds. Or maybe, can you still see this? Or is it too small? Okay, let's just do this. Okay, imagine we have 10 moles of the following compounds. Which sample is the heaviest and which one is an ionic compound? So if you have something like this in test and then you're stressing out about the time, so what you can do is that first answer something that you know, or like is the definition. Which one of these are ionic compound? Why? Exactly. But remember, ammonium is your exception because this is cation. Ionic compounds are composed of cations and anions. So even if you don't have nonmetal, you may have ionic compound. So remember that. But except ammonium, most others are like metal, nonmetal. So you know that the other ones are not ionic compounds. So your answer is between these two. And then, which one is heaviest? It means that which one has the most grams in it, right? And these ones we went through a lot in the class. You know, you want to find grams of the compound. How many grams of the compound equals 10 mole of the compound, right? Or like I just write compound. Multiply by mole of compound and then gram of compound. And this number, you know, is your molar mass. And you know how to calculate molar mass. So for MgSO4, you go to your periodic table, which I'm going to include again, because that's faster for me to do. I bring it here. Okay. What is the number for Mg? Exactly. So, how many sulfur do I have? Yes. And then you read that number, and then how many oxygen? What is the atomic mass of oxygen? And then, so you put this number in calculator, but if you even don't have, you know, you kind of like, so this is like 64 plus 32, which would be like 98 plus 24, which would be 122. So this is the rough answer, but you put the number in the calculator. I just want to show you how to solve the problem. And then for, oh, actually, I just needed to, you know, calculate between these two, but oh well. So, but this is the procedure, Ni3. How many Ni? What is the atomic mass of Ni? Yes. What about I? How many? Yes, 35 point, oh, sorry. You said the right thing, I just wrote the wrong thing. 126.90. And then let's write for BRF52. So how many BR? What is the atomic mass for it? Right? How many fluorine? What is the atomic mass of it? So now you want to compare these two numbers. This is roughly 127 and 14. And then if you add those numbers, is almost 141. This is almost 80. And then this is almost 95. Adding them would be 175, right? Okay, good point. Yeah, I was like, the number is different from what I remember. Is this right? Okay, cool. Thanks for noticing. So, if I do this calculation, so this would be like in the order of, I think, almost 485. Is this what you guys have? Let me just see. Okay, so this number exactly, maybe just erase this. 1 multiplied by 14 plus 3 multiplied by 126.9 would be 394.71. And this number would be exactly 180.47. So you see that Ni3 is largely, heavier. So this is your answer. Any question about this? So is it clear how we do these problems? So in most problems, you should calculate molar mass or formula mass, which are the same numbers. Okay, so next one, I'm going to write with blue to make it prettier. Which compound name is correct? Calcium 2 oxide. True or false?
False.
Why?
Calcium's an alkaline and also has a big.
Exactly, so it shouldn't have this. This is wrong. What about KNO3, potassium nitrite?
Wrong.
Yes, why?
Nitrate.
Exactly. What about iron oxide?
You would have to have the charge for iron.
Exactly. We should have a 2 here. What about ammonium nitrate? Is it true or false? Yes. So remember, do you have a metal here?
No.
But you have a cation, ammonium. So remember that. So it says we have 10 grams of each of the following compound. Which of them consists of the least grams of oxygen? We solve several problems like this. You always write what you want to calculate. On the left, how many grams of oxygen equals 10 grams of the compound. And I was told that, Professor Stelks was writing this like this for you. So whichever you're more comfortable, that doesn't matter, Just the procedure is important. And multiply by gram of compound. Pound to mole of compound. Mole of compound to mole of your element. Here, mole of oxygen. And then mole of oxygen to gram of oxygen. So you always convert gram to mole, mole to mole, mole to gram, and then convert from your compound to your element or vice versa. So first, let's write these names. So what is copper 1? How do you write it? So copper is Cu, right? So when it's 1, it means that it has charge of +1, right? And then chlorate, again, I told you, files, polyatomic ions, done. Okay, here you see chlorate, right? So it would be ClO3 minus. Since the charges are the same, you don't have to balance anymore. It would be like CuClO3. So you just write this as CuClO3. I guess I'm going to get rid of this, to not being confusing. Any question about this? Okay. Potassium permanganate. You go to your table of polyatomic ions, you find permanganate. And again, the charges are the same. So you don't have to do anything further. You just write KMnO4. And then lithium, which is Li+, hydrogen sulfide. You come here, and then you find hydrogen sulfide, which is SHSO3 minus. So this one doesn't need any adjustment either. Is this clear how to write from their name to formula? Any questions? Okay. So now that we wrote this, here we just substitute, Let me just use the blue again. So here, you calculate formula mass for each of these. For this would be 1 multiplied by Cu plus 1 multiplied by Cl plus 3 multiplied by oxygen. Here it would be 1 multiplied by K plus 1 multiplied by N plus 4 multiplied by oxygen. Here 1 multiplied by Li plus 1 multiplied by hydrogen plus 1 multiplied by S plus 3 multiplied by oxygen. And then you find the numbers for each of these, which fortunately I already calculated. So this one would be 147, this one would be 158.04, this one would be 88.01. And then remember here, when you want to write these conversions from mole to mole, you just look at chemical formula. So here, 1 mole of CuLO3 has like 1 mole of Cu, 1 mole of Cl, 3 moles of oxygen. So you just count the atoms in that chemical formula. That would be your mole conversion. Here, 1 mole of KMnO4 has 1 mole of K, 1 mole of Mn, 4 moles of oxygen. Here, 1 mole of LiHSO3 has 1 mole of lithium, 1 mole of hydrogen, 1 mole of sulfur, 3 moles of oxygen. So it's kind of straightforward. Just see how many atoms in the molecule you have, and that would be your conversion factor. So here, for instance, I do for like CuClO3. Here, 1 mole of it is 147. Here, 1 mole of compound has 3 moles of oxygen. 1 mole of oxygen has 16 grams. And remember, for all of these calculations, these 10 is the same because you are given the same amount for all of them. For all of them, molar mass of oxygen is the same. So the only thing that is changing is your chemical formula and this molar mass of your compound. So for the first one, you will be having for this portion only the thing that is different. Or maybe I just write the whole thing. So what I'm trying to tell you, if your exam, you're short on time, and then you cannot solve the problem completely, you can just write these numbers, because these are the ones that are changing, these ratios for A, B, C, and then compare those 3 numbers. Does that make sense? Because you're just comparing which number is the smallest, which one has the least gram of oxygen. But regardless, when you do that for each of them, so let me write these ones too. So these ratios that I talked about for A basically would be 3 over 147. For the B would be like how many oxygen? For B would be 4, right? Divided by 158. For C would be how many oxygen for C? And then molar mass, 88. So for these two, because they have like the same numerators, the one that has bigger denominator, the number is smaller. So automatically, this is not our answer. Between these two, you just compare which one is bigger. And you know that how to compare these, right? 3 multiplied by 158. So this number is almost 450. This is almost, if it's 150, would be almost 600. So this number, basically B, is the, or did I do something wrong? What's that? Yeah, you can just do that. I was just trying to do that without calculator. So let me see. So 3 over this, 4 over this, and then 3 over this. And then we want to find the smallest. Oh, okay, sorry. Yeah. So this is correct, yeah. So we want to find the smallest number. So this is a smaller, right? Which is like A, which is, or, so let me just write the numbers to prevent confusion. So for the copper 1 chlorate, it would be 10 multiplied by 3 multiplied by 16 divided by 147, which is like 3.26 gram. For the other one would be 10 multiplied by 4 multiplied by 16 divided by 158.04, which would be like 4.05 gram. And then for the other one would be 10 multiplied by 3 multiplied by 16 divided by 88.01, which would be like 5.45 gram. And then I asked you least grams of oxygen, which is like this one, which is like copper 1 chlorate, right? Any questions about this? Is this clear how we do these things? Okay, if there is no question, I'm going to go to problem 7. Okay. It says sort option 1, option 2, option 3, and option 4 from smallest to the greatest values. So it's just like the problem has like more sections to it, but the procedure is basically the same. So, okay. Mass of chlorine in chlorous acid. How do you write chlorous acid? So you go to your table of polyatomic ions, you know that chlorous, let me just bring the table. Okay, you have this table. How do you know what was the ion for chlorous? Exactly, it ended with OUS. And then you remember that which one was OUS. If it was ending in 8, it would be, the acid would be ick. And I was telling, students that it's as if like you ate or I ate ice. Like 8, or like your book was saying 8 acid, but never eat acid. But just as a way to remember, 8 would be icy, but OUS was like ite. So any of these ions that has like ite, ite, ITE basically, those would be OUS. So it would be like base name of the polyatomic ion plus OUS plus acid. So, for instance, nitrite would be nitrous acid. Hypochlorite would be hypochlorous acid. Sulfite would be sulfurous acid. And then the same thing, chlorous acid, it would have been chlorite, right? Is this clear? Okay, so here it would be like H, and then you write this, ClO2. And then what about nitric acid? It says same, it's like the other one, right? I said 8. If it ends with ATE, nitric. So you go to your table, you know that it probably would be, here. Nitrate, right? That 8 would be ick, kind of. So it would be like HNO3, right? And then the same thing with acetic acid. It would be acetate. So it would be HC2H3O2. And then sulfurous acid is like this one. So it would end with ite, sulfite. So H And then I have like, so here, SO3 2 minus. In order to be, neutralized without charge, I should have like 2 hydrogen here. So is it clear how to write this? So remember, if it ends with ite or acid, it would be like OUS, like sulfurous acid, nitrous acid, nitrite. And if it ends with ate, like acetate, it would be acetic, IC at the end, acid. And then when you write this, if I can get rid of, I guess, okay, I try to write neatly. So it says which one, sort these based on like smallest to greatest values, basically smallest to the biggest number. So mass of Cl in 15 gram of chlorous acid. The procedure is the same. I kind of like just give you the procedure, and then, if you go through it, solve it, if you cannot find the solution. And I'm going to also, write the solutions, in a piece of paper, take pictures, upload it to the website, and also, I send announcement in BBLearn. So you have like the neat solution, so you can go through it and study again. So I'm just going to give you the procedure and then solve the solution and then post it. So here, we want to find, which one is greatest. Mass of Cl, you want to find how many gram of Cl equals to 15 gram of chlorous acid. So it's kind of like just similar like the problem that we just solved. You convert gram to mole of compound to mole of your element, mole of element to your gram of element. So here you write gram of HClO2 to mole of HClO2 multiplied by mole of HClO2 to mole of Cl, and then mole of Cl to gram of Cl. And with the periodic table, you calculate formula mass or molar mass, and then write the number here with molecular or chemical formula, rather. You relate these numbers. Can anyone give me this ratio? Yes. In 1 mole of your compound, you have 1 mole of chlorine. And then here, again, you go back of your book and the table that I give you in the exam, read this number for chlorine. And then calculate this number, which, based on what I have in my notes, it would be, it would be like, 7.77. But you go, do that for like B, option 2, option 3, option 4, and then, compare the numbers. So as I said, I'm going to write this in a piece of paper, upload it, so you have like the neat solutions. But is it any question on how we do this? Clear? Okay, let me go, if I can. Okay, let me just go bring this one again. Okay, which sample contains the most number of atoms? 1 gram of cobalt, 1 gram of carbon, 1 gram of lead. So do you remember how we relate number of moles or like grams to number of atoms? Anyone? Exactly. So we say we want to find number of atoms. How many number of atoms equals 1 gram of cobalt? You convert gram of cobalt to moles of cobalt because you don't have a conversion between gram and number of atoms directly, but you have a conversion between moles and number of atoms. And then you go back of your book, read the number for cobalt, and then you convert mole of cobalt to gram of cobalt. And then for cobalt, this number is like 58.93. And then 1 mole of cobalt has like 6.022 multiplied by 10 to the power of 23. And then you do the same. If you do the same for like the other ones, you realize that this ratio here and this one is the same. So the difference would be only, here, like for carbon, the number would be 12.01. For lead would be 204.2. And then when you want to see which one has the most number of atoms, so the denominator should be the smallest. So that would be like carbon. But you can also calculate the numbers. But when I give you something like this in the exam, you can just refer to your periodic table, see which one is lightest, which one has the, least mass, and then that would be having the most number of atoms. Is that clear? And I gave you some questions in the exam that I say you can answer this question without a calculator, but you are welcome to use. So for those ones, you can just save time by kind of like just comparing the numbers like this one. But you are welcome to do calculation as well. The first one, it says fluoride is often added to water as sodium fluoride. What is the mass percent composition of F in sodium fluoride? How many grams of sodium fluoride must be added to 1,500 liters of water to fluoridate it at a level of 1 milligram per liter? So, how do you calculate mass percent composition? Do you remember the formula? Yes?
Can you please repeat the answer to 7?
Yes. So for each of these options, this is like basically 4 problems. So for each one, you want to calculate mass of this specific element, and then you are given, basically you have mass of compound. You want to compare it to mass of the specific element, right? So if you have the mass of compound, first you convert the mass to like the moles, and then convert moles to moles, and then convert the mole of the element by molar mass to the grams of that element. Is that clear?
Like what letter answer is it
For
for 7?
7, your answer is B. So if you remember, when you want to calculate mass percent composition, you have 2 ways. Whether you use the formula in the book, which is mass of your element in 1 mole of compound divided by mass of 1 mole of compound multiplied by 100%. And I had people in their quizzes that, they forgot to calculate, basically multiply by 100%. Remember to do that. And then, or just, calculate the mass of your element in 100 gram of your compound. So basically we say how many gram of F equals 100 gram of NaF. And then the procedure is the same. Gram of NaF to mole of NaF, and then mole of NaF to moles of F, and then moles of F to gram of F. And then when you calculate these numbers by the rationale that I just gave you, 1 to 1 with the chemical formula, 1 is 19, that would be 45.25%. And then next part of the question, it says, how many grams of sodium fluoride must be added to 1,500 liters of water to fluoridate it at a level of 1 milligram per liter. So you have like one more conversion factor here. So you convert, you want to have the level of milligram of F to liter. So you want this to be 1 milligram per liter. Liter and liter already cancel out. And then multiply that milligram to gram. You know that 1 milli is 10 to the power of minus 3. And then gram of F to mole of F. And then this number would be 19. And then you convert to mole of NaF. Basically, these two cancel out. And this is 1 to 1. And then mole of NaF to gram of NaF, which this number is like 41.99. And then when you do the basically do the math, it would be 3.315 gram. So this one, not milligram. So basically, you have just one more conversion factor that you should include. But as long as you know how to cancel these out, you're good. Any question about this?
Are we expected to know like liter to gram conversions?
So you don't need, here you should know how to write the conversion factor. So gram per liter. But you are not, basically you don't need to memorize anything. So the rest of the quiz, with the same way that I explained right now, I'm gonna continue from question 10 and then record the video like what I did just in the class, and then I will add it as another like section 2. I said the rest of the quiz. So you have, the ability. I just wanted to go in more details into the problem so you know how to solve the problem. And I'm going to also write the solutions and post it so you have like the solutions as well. And again, if you don't give me your solutions, your quiz would be incomplete. You should, come to me, talk to me, or email me and schedule a time to just like walk me through the quiz so I make sure you did that yourself.